And let me tell you a little bit about Bill Capralos before we get started. So he is going to talk about immersive technologies and medical education. And a little bit of background knowledge about Bill Capralos. He is an associate professor from Ontario Tech University, um, and he also has a PhD and is a co-director of the Max Sim Health Group and the technical lead of the Collaborative Human Immersive Interaction Laboratory. That also is including the Sunnybrook Health Sciences Center in Toronto, Canada. His research includes immersive technologies, serious gaming, environments, simulation, and reality. That also includes the perception of auditory events and 3D spatial sound generation. So I'm extremely excited for you guys to be introduced by Bill Capralos. And without further ado, I'm going to give Dr. Capralos the floor and take it away.
So, hello everyone, and I'm hoping everyone can hear me. So I'm Bill Capralos, and I'm going to talk about immersive technologies in medical education, and of course, the joining of the two. And just a little bit about myself, just a minute here. So I'm an associate professor at Ontario Tech University, and for those that don't know Ontario Tech University, it's in Oshawa, which is just about 70 kilometers east of Toronto. And one of the things, we have a game development program, which focuses, obviously, it's a degree program that focuses on gaming. And a big part of that also includes virtual reality and immersive technologies in general, with an emphasis on serious gaming and virtual simulations. I'm also a faculty member in the Maxim Health group, which is an interdisciplinary medical education group, also at Ontario Tech. And my research interests include immersive technologies, serious games, multimodal virtual environments, perception of auditory events, 3D spatial sound generation. And I have extensive experience in developing interactive virtual experiences, particularly serious games and virtual simulations for medical education. And of course, I come with a computer science background. So I don't have a medical background, but I work with a lot of folks that have expertise in medicine, whether it's surgery, nursing, and medical education as well. So we're part of an interdisciplinary team, a collective. So just a brief overview of the presentation today. I'll introduce simulation, move into play games, video games, and serious games, talk about immersive technologies, and of course that divide between video games and immersive tech, such as virtual reality and augmented reality. That divide has disappeared. They're pretty well, I'll say, the same. Obviously, there's going to be some subtle differences. I'll briefly talk about designing virtual immersive experiences, and I'll provide some concluding remarks. And one of the things that I will, and I'll point this out towards the latter part of my talk, for the students present right now, and we're in this, horrible situation, the COVID, the pandemic, and there's obviously a lot of, medical related issues and a whole slew of other issues. But I won't talk about those, of course, but in terms of, the technology part, this is actually, I look at this as, yes, it's disrupted, how we teach, and we're learning from home, many of us, behind their computers, but it's also provided a lot of opportunities when we're talking about the virtual domain and using virtual environments for training. And so you can look at that as an opportunity here. And, the technology, if it wasn't for technology, we'd be in a far worse situation with respect to education and training. So technology has provided, is definitely a bright spot here in the sense that it's allowing us to do things that we wouldn't be able to do otherwise, given the circumstances. So just something to consider here. This fear of technology is not a new phenomenon. And, I always like to start when I'm talking about immersive tech, probably not so much to this crowd, but a lot of times there may be some naysayers and people who have doubts about technology in general. I think that's quickly moving away over the last number of years, particularly when we consider the COVID pandemic. But going back about 400 or 500 years BC, so about 2,500 years ago, Socrates, the famous Greek philosopher, stated, and I'm quoting him, "This discovery of yours will create forgetfulness in the learner's souls because they will not use their memories. They will trust to the external written characters and not remember of themselves." And what he was talking about here was the technology of the day, which was the stylus, basically the pen. And he thought by having his students use the pen to write what they were listening to, what he was telling them, it would take away from their ability to, to hear it and memorize it. And this also, even more recently, going back about 500 years, Conrad Gesner, information overload. You must regulate the trade so public won't suffer with the confusing and harmful abundance of books. And he was a publisher, and he was, or sorry, not he was concerned about books and how that's going to, just create information overload when you provide information to people as it was in books, appearing in books. I mean, if only he could see what's happening now with information overload. But nonetheless, and just one more quote here. Marshall McLuhan, a famous Canadian philosopher, known for coining the term global village many, many years ago. Anyone who tries to make a distinction between education and entertainment doesn't know the first thing about either. And I really like this quote, and I think it goes nicely with what I'm going to be talking about over the next 30 minutes or so. So simulation. Probably don't have to, when I use the term simulation, it probably, many things can come to mind, but you're probably thinking along the same lines here. In medicine, you have the physical mannequins, and you have a team, one or more of medical trainees performing some procedure or operation on the mannequin instead of a human being. And of course, the mannequin represents a model of the human, and we're able to perform and practice techniques and procedures before we become experts and do them live on a real body, and learn in the process. You can make mistakes on the physical mannequin without the real world consequences that would result if that mistake was made on an actual human. Similarly, pilots, for the most part, whoever's been on a plane, the pilot that flies your plane has trained in a simulator. But simulation goes back thousands of years. It goes back to the ancient Greek and Roman soldiers who would practice their sword techniques on trees, for example, tree trunks. And of course, the tree there represented or was a model of an enemy soldier. Now, of course, that model, the fidelity or the realism of the model was not very great because a tree trunk does not move, whereas an actual soldier moves. These models later evolved and they became more realistic. You had parts of a tree trunk hanging off another tree, for example, and the swinging back and forth as it was hit better represented the human enemy. Currently, simulation is used widely in medicine and in the military, or by the military. And the current focus, and it has been for the last number of years or decades, last few decades when we're considering the military, is the use of immersive technologies and virtual and augmented reality in particular, in addition to serious games. And of course, I'll talk about these as we progress. Moving away from simulation, we're going to get into play games, video games, and serious games. But another quote, what did Einstein think about play? And this is one of his quotes. Play is the highest form of research. Again, I'm just trying to strip away move away from the fear of games in education or simulation in education, as often is the case, or at least was the case for a long time. When we look at play, basically we're engaging in an activity for enjoyment and recreation, rather than for a serious or a practical purpose. In other words, we're doing something strictly for the fun of it, because we enjoy it, we like it. And when we look at play, if you look at the animal kingdom, play is actually common. All animals, they play. They play when they're young. And what they're doing when they're playing is they're actually learning real world survival skills. And if you look at the left of my screen, you have the lion cubs, and they're, kind of on top of each other, or, they're playing. They're not hurting each other. But when you look at the rightmost figure here, you have the male adult lion taking down prey. And if you look at it follows a technique to take down its prey, and it has to eat, it has to kill its prey and eat in order to survive. Well, that technique is mimicked by the lion cubs, and they're able to do that and practice and practice and practice until they are able to do it and eat and survive as a result. From play, we move into a game. And a game is nothing more than play with additional rules and goals added to it. So it's kind of constrained play, you can look at it as. And humans have played games for over 4,500 years. At least that's how far back, that's the proof that we have. It's debatable whether we go further than that. And some games include Royal Game of Ur, Ancient Iraq. It's roughly 2,000, 2,500 years, or 4,500 years back. Similarly, the Game of Senet, an ancient Egyptian game. So games, we've been playing games for a long, long time. And of course, games have also been used as simulation. And the first simulation game that comes to mind in many people is chess. And basically board games such as chess were used to simulate real-world activities instead of for their fun. And chess was one of the first games that really came to that. It was 6th century Northwest India. And it was actually used to teach military strategy. From games, we move into video games. And video games, a video game is nothing more than a game, except now where the medium changes. So, rather than having a board with physical pieces, as in chess, for example, we're basically controlling and manipulating images on a video screen. So we remove the board and we play via, or we're manipulating images that are displayed via a video screen or a monitor. And there's actually plenty of learning that occurs when playing a video game. And if you don't believe me, try any video game, try playing it. It's going to take you some time from the start until you're able to finish the game. And video games have been around for a long time. And first one, Space War, 1961, it simulated space battle. And this became the first commercial video game, which was known as Computer Space back in 1971. And of course, Pong in 72 and Pac-Man in 1980. These are classics. Video games, big business. 2019 global market value was 120.1 billion. Just some mobile gaming accounted for 64.4 billion. Epic's Fortnite, 1.8 billion. That's one game alone. PC games, 29.6 billion, and the list goes on. The interesting thing about here is that extended reality, which for now I'll just say that it's virtual and augmented reality, accounted for 6.3 billion. So again, and this is a growing number. Okay, and we're playing games. By age 21, the average American will have spent more than 10,000 hours playing video games. We play games, and I think it's safe to say it. It's no longer just adolescent males that are playing first-person shooters. Everyone is playing games. Even the very old are playing games. And this ties into serious games. And serious games are basically video games that have been designed specifically for education and training purposes rather than entertainment. So their primary purpose is education and training. It's not to say that they're not fun and they shouldn't be entertaining. Of course, that's the whole point. You're tapping into the engaging and the fun aspects of video games and the fact that we play them for those reasons and we're applying them to education and training. And what I like to just bringing this all together, we've been using simulation for thousands of years. We've been playing games for thousands of years. And, you can look at, simulations are games themselves and serious games are games as well. Or games are simulations and serious games are games themselves. So why not combine the motivational and engaging aspects of video games with simulation and learning? And that's exactly what we're doing with serious games. And when you couple immersive technologies such as head-mounted displays and haptic devices and what have you. You can create these very engaging and very motivating educational applications. And serious gaming trends, currently it's estimated to be a roughly $3 billion global market, US dollars. And it's estimated to grow by 8.1 billion next year. And again, this might even grow more given the pandemic. And there's some big players, Breakaway Games, big American gaming company that does a lot of work on serious gaming. They've done great work with the US military and some others. And in March of 2015, Ubisoft, it announced Dig Rush. And Dig Rush is the first therapeutic video game to treat amblyopia. And it was, the interesting thing about Dig Rush is it was the first video game. Well, first off, it was Ubisoft, one of the big players, big AAA video game makers. They, got into the serious gaming field. And then the other part was that Dig Rush itself it can only be acquired by prescription. So the doctor had to actually prescribe it. And there's some other, a whole bunch of other games I'll briefly look at. There's one, hopefully the video will play here.
Foodbot Factory is a tablet-based game for kids focused on teaching the main food messages of the new Canada's Food Guide. More specifically, it was created to align with the Ontario Health Curriculum.
I'll just briefly say Foodbot Factory was a game that myself and my group worked on, and it was to teach kids about nutrition, kids in grades 3 to 6. And basically, it was an app-based game. We did a lot of work with it in terms of, we put it out to schools. We've done a lot of studies with it, and it is an effective, our studies do show that it is an effective way to actually teach kids about a topic that was traditionally taught with pamphlets and very archaic websites. Now we'll move into immersive technologies. And immersive technologies, it seems like it's this latest and greatest tech and it's all new, but in reality, immersive technology is not new at all. First off, let me describe what it is, and I'll use this definition. I don't like quoting Wikipedia only because it's not peer-reviewed and for all those reasons. But nonetheless, I really like this definition. Immersive technology is technology that blurs the line between the physical world and the digital or the simulated world, thereby creating a sense of immersion. And the key here is this sense of immersion, that you're able to suspend disbelief. In other words, you walk into a world and you believe it, you're in it. And a good example of that is a novel. I mean, we're going low tech here. It's a novel. You read a novel and you can't put it down. And this is what immersive technology helps us do. It's not to say that you can't be immersed. You can be immersed in a game or a novel. For that, you don't need the tech, but it can help us make that, can help us with the immersion. Now, of course, immersive technology is nothing new. It's been around from the 50s, and Sensorama was a device, an immersive technology, or an immersive technologies device that allowed users. And there's the picture here. It simulated a motorcycle ride through New York City. And obviously, it had you were looking into a display. So you had still images that were moving. So it wasn't a video. But again, you had visuals, you had fans blowing air on you to give you that air, to simulate the air that's you'd encounter if you're riding a motorcycle and what have you. So again, going back, 60, 70 years. So immersive technology has become synonymous with virtual reality and augmented reality. And when we couple this with serious games and virtual simulations, it can lead to very engaging learning applications, as I pointed out earlier. So we can take the serious games, which are fun, which are engaging, and we're motivated to play, and we can add these, further immersive tools to them, such as head-mounted displays, haptic devices, and what have you. And we can create these, very engaging learning applications that'll allow us to do some really good things. We can simulate surgeries, for example, and with haptic feedback and create these very engaging applications that are very safe and I'll say cost effective in quotes because there still is a cost associated, but very safe with respect to how we do them currently, how we train currently, whether we're using cadavers or physical mannequins. So while the hype recently, well, there's over the past, I'll say, more than decade, but over the past few years, the cost of electronics has shrunk. It's come right down. And in addition, the electronics themselves have become smaller. And this has led to consumer level immersive technologies. And prices come down, they're more affordable. And it's provided this technology to the masses, essentially, to a bigger audience who can then go in, develop, and then the technology comes, down even more and what have you, as we buy it more and we use it more and we develop it, we buy more, and the technology improves, keeps improving. So again, it has been suggested that in medical education, virtual reality and augmented reality will drive a revolution in medical education and patient care. And this has only been accelerated by the current pandemic that we're in, as medical schools struggle with the use of in labs, in bringing trainees into simulation labs. There's all kinds of issues associated with that. So a lot of it is moving to the virtual domain. Still many problems that have to be figured out, especially when you're dealing with psychomotor skills, such as actually using a scalpel to cut through, layers of skin. That becomes a problem, but we are moving towards this domain, and the COVID pandemic has really accelerated that. Virtual reality, it's an artificial 3D sensory environment. It's an interactive computer simulation that senses the user's state and operation, and it replaces sensory feedback to one or more senses in a way that the user obtains the sense of being immersed in that virtual environment. In other words, ideally it involves all of the senses. Realistically, we're involving the visual sense with a head-mounted display, and we're able to see stereoscopic 3D. In other words, we can see depth. And to a smaller degree, although it's growing, the auditory sense. Haptics, or the sense of touch, is becoming more prevalent, but again, simulating the sense of touch is still very expensive, or at least to do so in a very high fidelity or highly realistic manner. Augmented reality, we're combining the virtual domain with the real world. And basically, we're taking the virtual representations or the VR representations, and we're combining them with real world information. And this is actually a really big use in medical education in particular. And if you look at some of the slides, or the the right and the middle slide, you can see on the rightmost slide, you have an individual, a human, and looking through a pair of glasses, or perhaps even your tablet. You can place it over or look at their midsection, and you're able to see an overlay, a virtual overlay of the internal organs, for example. And now you can picture being a medical trainee, and you can put your tablet over a cadaver, for example, or simulated patient, and you can have information about what the body parts with labels and what have you. So very, very useful when we're dealing with medical education. And just some of the uses here of immersive tech in cardiology education, for example. Just go over some examples here. Stanford University School of Medicine, and I'll just read this. It was actually from the Dr. David Axelrod. The heart is a complicated three-dimensional organ, and it's really hard to describe what's going on inside of it, especially when something is going wrong. Virtual reality eliminates a lot of that complexity by letting people go inside the heart and see what's happening themselves. It's worth way more than 1,000 words. And again, David he's an assistant professor of pediatric cardiology at Stanford. And again, and I bring this example because it's being used in medical education right now. There's issues, and there's still a lot of work to be done, but it's being used, and it's providing, there's a lot of use for it. Anesthesia training, this is work that I've done with, and we're working with anesthesiologists at Sunnybrook Health Sciences Center in Toronto, Canada. And we're doing a lot of work with using virtual sims with head-mounted displays, VR-based, to train or to provide anesthesia-based training. And this goes on. We're also doing some work with ophthalmologists to teach fundoscopy skills. This was a serious game with combined virtual reality. And one of the things that we're really, or at least my group, and a lot of other groups for that matter, I'll just talk about this project. Again, we're trying to move into that psychomotor domain where we're practicing psychomotor-based skills that involve doing, rather than, if we look at a lot of the sims that we have today in the serious games for medical education, they're based on the cognitive aspects of a procedure. So for example, what are the steps that you have to take, for example, to perform a knee replacement surgical procedure? Rather than going in and actually doing the procedure, in the virtual domain. So going in, using the, cutting, doing the cutting and what have you. What we're doing is we're incorporating haptics to simulate the sense of touch. And again, with respect to anesthesia-based training, we've done some work with simulating the epidural, giving an epidural procedure. And this is a really neat project using a consumer-level haptic device together with some 3D printing and open electronics, some Arduino kits, and we were able to simulate, fairly decently the giving or the injection of an epidural. Another big part of immersive tech in medicine, or for medical education in particular, virtual patients. So they allow for safe and repeatable exposure to various medical scenarios. So again, we're able to we can interact. We can have the medical professional, whether it's a doctor, a nurse, a surgeon, interact with a patient. And again, here we're able to look at effective computing. So how we can with using eye trackers and physiological sensing, for example, heart rate, things like that, we're able to detect the user's emotions. And we can incorporate that into the dialogue that the doctor or the medical professional has with the patient, and really simulate this, very accurate, or not, a more realistic, I should say, interaction between a health professional and a patient. And this actually, there's also been a number of studies that have used that have virtual medical professionals, and we can have the patient, an actual patient, interact with a virtual medical professional. And there's been studies that show when we do that, the patient is actually more honest and more likely to reveal, truths about themselves and their potential conditions to a virtual patient than they are to an actual medical professional. Breakaway games, I mentioned earlier in the talk, they've done some really great work in the virtual domain. And they have this interactive virtual healthcare learning environment. And it's a very immersive, realistic virtual environment for, I'll quote, I took this from their website, for discovery-based learning and decision-making skills required to communicate effectively with a patient's clinical care team. So they're looking at critical care and emergencies and dealing with unforeseen events, and how the trainees handle these unforeseen events. And their simulations, they've done work with the U.S. military, and their simulations are in the millions of dollars, so very realistic. So give you a little kind of overview of immersive tech and how we can combine them with virtual or with serious gaming and create these engaging learning experiences. I'll just briefly go into designing immersive experiences, and again, I'm hoping to talk to the the students here, because there's a lot of opportunities for students in these domains, whether it's computer science or gaming, simulation and gaming. I know the University of Tulsa has that program, and these are great opportunities for you. So think it's not only entertainment-based gamings and creating these AAA games. That was the big drive for a lot of students getting into gaming programs, at least in my program, which goes back about 15 years. One of the first in Ontario, if not Canada. Everyone wanted to make these, AAA games, and they wanted to work for the big studios. But that has shifted now because there's so many opportunities in the non-entertainment application of immersive experiences, serious games and virtual simulations in particular. So first off, what I want to say is that it's not a trivial task. Developing these sims, it usually takes, well, at least in my experience, it always takes an interdisciplinary process. It involves the computer scientists, the game developers, the educators, if it's medicine, the medical educators, and of course the content experts. And the key here is never start by jumping in to writing code. There is, and I can't stress the importance of this, you have to make sure that you do the appropriate design. And by design, I mean the needs and task analysis. You have to think about what are the goals of the sim or the game that you're creating, and what are the goals, and who is your target audience. And I can't stress that enough. If you're designing and developing these sims for medical students, it's far different than developing a game for high school students, for example. So you have to know about your audience, or if you're developing something for a more senior practicing physician or surgeon, it's going to differ than what you're going to do for a trainee. And this may help you and provide you information with what type of fidelity, realism that you're going to use in your sim, in your game. But you have to really account for that. And of course, you should follow an iterative development process where you develop a prototype, you test, you refine, and you keep going through that cycle. So yeah, as I pointed out, be aware that this is an interdisciplinary process, and you have to keep in mind that myself as a computer scientist, I'm not a medical expert. And I have to rely on the medical experts for the content. And typically, you have to also keep in mind that this can lead to some problems, in the sense that sometimes different areas or different disciplines may refer to the same thing in different terms. So there's different terminology and what have you. These are things that can easily be worked out, though. And you have to also be aware that content experts may not be aware of technical limits. And I've talked with many medical experts that have reached out to me about developing a game to teach something, and they'll say that I want this and I want that, and it's got to be and I want it all in 2 weeks. And I told them, you might get a piece of that and you might get a piece of this, and it'll take a year to develop, or a lot more longer. So just be aware of that. We also have to really let the content experts know, and the educators, that there are limits to education. And of course, how do you combine instructional design or the educational aspects with game design? There has to be a synergy between instructional design and game design. And it's not to say that one is more important than the other. I think they're equally important, and you have to start together. When you're doing the design, the needs and the task analysis, you should always think about the game design as well, and you should work together on what not only you got to work together on both parts. And just keep in mind that when you're dealing with when you're designing sims and serious games for it's not like designing entertainment games, in the sense that with entertainment games you have a clean slate. You can do whatever you want. But when you're dealing with serious games and virtual sims for a particular purpose, the book of content, so to speak, already exists. You can't change the content. Okay, so now you have to work around that content. Yeah, I'm not gonna. Okay, so I'm gonna just wrap up here, and I'm going to give a few concluding remarks here. And what I want to say is, and again, I talked about this a little bit earlier, but the first thing I want to consider is the COVID-19 pandemic. And it has shifted traditional educational approaches in medical education, actually in education in general, not only medical education, from in-person to remote learning. And, although it's, perhaps, at least, in the university level, things may be opening up and starting in the US. Here in Canada, things have not opened up yet, at least with respect to universities. And pedagogical strategies have been implemented rapidly to support cognitive and affective domains of learning. okay, in medical education in particular. But now and we have those in place. But again, psychomotor skills based training, where you're learning by doing, so to speak, hasn't it's lagging behind. And again, a lot of that are hardships with technological problems and constraints and costs too. But that is changing. And again, the COVID pandemic has led to some really innovative developments. So immersive technologies in the form of virtual sims and serious games are gaining popularity. And this popularity has been accelerated during COVID. So again, it's a lot of opportunities for the developers in the audience. Okay, and yeah, so something else that you have to remember though is that there's far more than designing virtual immersive applications, whether it's virtual sims or serious games that has been presented here. Do a rather quick overview. And you have to keep in mind that making an activity fun by throwing some coding over it doesn't really help in the end. And it's just like taking broccoli and covering it with chocolate. When you take a bite through it, it's still broccoli. So it's not just about using the latest and the greatest technology. And again, I'm going to go back to what I said earlier. Proper design and testing is a must. And we can't downplay that part. You really have to design properly. And the other thing that I want to just consider is how much realism and fidelity is actually needed. If you look at a lot of the, even the gaming industry, it was always, this focus on greater and greater and greater and greater realism. And that was actually not a bad thing, because it gave us, the great computing power, the GPUs that we currently have, and we could do a lot of things with them. But you have to keep in mind that perfect multisensory fidelity is impossible to achieve with the current technology. We can't faithfully recreate visuals, the auditory, the sense of touch, smell, taste. We just can't do that with the current tech. So something has to give. And how much realism is really needed to maximize learning? I'm going to say that's an open question. And realism, you can also hear the term fidelity, and fidelity is known as the F word, because there really is, how much of it is really needed. It's not, we know now that it's not, the greater and greater realism is not always the answer. It really depends on the level of the learner. Are they novices? Are they experts? And it depends on the task or the goal of what you're trying to achieve. Okay. So again, unclear if high realism is needed for their enjoyment or to maximize learning. And when some cues are too realistic, we get into the Uncanny Valley effect. And that can sometimes creep people out. And in robotics, that's a very well-known effect. And just going back to what I said about realism, again, we always wanted the latest and greatest, most realistic graphics when we were dealing with entertainment, first-person shooter games. Then the Nintendo Wii came along, and I think it just completely blew the need for realism, right? I mean, it could, because now we focused on interaction. And, we are moving, and where are things moving to? Technology keeps improving, things get smaller, and price comes down. And that spurs further development, because now more people can buy the devices and the VR headsets and what have you. And then that spurs more development. And we have 3D printing, and we can do some really neat things just in, using makerspace type facilities. And I talked about earlier about the haptic device to simulate the epidural procedure. That was all done in-house with, a few $100s. And this is, coming to our homes. And, all the labs were able to, again, some of the work that I did in my lab too, we had 3D printed a surgical drill, attached it to a haptic device, a consumer level haptic device, and we were able to simulate surgical drilling. So what I want to say is that, I've reached the end, but I definitely don't want to say this is the end, because there is a lot more work that remains. So it's definitely not the end. And I'll just end it with a final quote from George Bernard Shaw, famous playwright, Irish, I believe. We don't stop playing because we grow old. We grow old because we stop playing. And I'd like to thank you very much for your time. Yeah, absolutely. That's a great question. And there's a lot of work being done in that domain. So the answer is yes. And I've actually worked with, or I'm working with number of medical folks that are actually looking, very seriously into this. And they see this as a very practical way of doing it, and a cost-effective and safe way of doing that. So the answer is definitely yes. I'm assuming there's some work in there already, or there may be some small. I haven't seen any large-scale acceptance of it, but it definitely is moving in that direction. Yes. So what we're doing there is we've actually simulated. So we have there's an actual epidermal. We have the needle, and we're able to simulate. What we're simulating is, so the user the needle, it's hard to see in this picture, but the needle is actually connected via some 3D printed components connected to the haptic device. And as the user pushes the syringe, we simulate the force they would feel if it was a human, that they would feel if that needle was going through the human body, the back, for example, or the spine, I should say. What I can do is, if you send me an email, we have a paper that describes that, and I'd be happy to send you a copy of it.
All right. And I guess are there any other questions here? Our next question here, and I do apologize to the audience. My mic was off, but I believe it's on now. But our next question here is from Robster9000. How big will the technology play in education, you think? So what are your thoughts on technology and education?
Yeah, I think another good question. I mean, it's I think we were moving towards the use of technology in education, medical education in particular. There's a big push here in Canada, and the US as well, that I'm aware of, but I can really speak for Canada. There was a lot of emphasis on moving into the virtual domain prior to the pandemic. And there was a lot of, and you can see this was evident in a lot of the medical organizations were offering grants. A lot of our granting agencies, national and provincial granting agencies, were focusing on virtual technologies, and putting a lot of money and emphasis into that. But also, when you look at the hospitals, a lot of the medical centers and hospitals in particular, it's really incredible to see how much emphasis the doctors themselves are placing on the virtual stuff, on technology in general, and in particular virtual reality. A lot of the hospitals now have virtual reality centers. They have simulation centers, and then they have VR, a part of that focuses on virtual reality and augmented reality and immersive technologies in general. And I've had a number of students of mine that have had full-time positions in such centers. So it really was moving into that domain, and a big part of that was because it did offer a relatively, I'll say cheap, again in quotes, because it depends, cheaper, I guess, than using these physical mannequins. And it was a very safe and effective way of training. And there's many other benefits. I mean, you could create scenarios, that any kind of scenario you wanted to, essentially, within reason, of course. And the thing with that is, right now, with the tech that we have, it wasn't really necessarily doing away with these physical mannequins, but these physical mannequins, and a lot of, and using cadavers, and, there's a lot of issues and costs associated with doing so. So what a lot of the groups that I work with, the virtual domain is one step, or it's one tool in this toolbox of training tools that we have. And what you have is, a lot of times you're using the virtual domain to better prepare you to work with the mannequins, or to better prepare you to go into these very expensive and high, very few simulation centers that have all this, that are very expensive to build, have all this, high-tech equipment in there and monitors and patient monitors and things like that. So you're making far greater use of your time by practicing in the virtual domain, say at home, for example, and then moving into these, very expensive simulation labs, which, there's a few of them, and therefore there's a lot of contention with respect to their use. Now that the pandemic came along, though, the virtual domain has really gained even more traction, and we're looking at it as a means of overcoming some of the issues that the pandemic saw, and in particular, this bringing of many people into the lab. And sure, there's still some lab use, but it's very limited, and there's a lot of issues. So the virtual domain has really accelerated further development and use in that domain. And what I think, and again, I can just speak for myself here, and from what I'm seeing, there are a lot of benefits to doing so. Again, you got to be careful because, but when when you look at younger kids, for example, are they motivated enough? And when you're dealing with medical education and you're dealing with residents and medical trainees, they're, obviously they're a little bit older, and a big part of that, they're very motivated and they're very driven. So this, is a really good tool to, good training tool. So hopefully that answered your question.
All right. There were a couple more questions, but unfortunately we're out of time. We encourage you. I'm sure Dr. Kapalis would be willing to answer any questions if you email him. And we want to give a big round of applause again to Dr. Kapalis in joining us today. Thank you so much.
Thank you, and thank you, everyone. It was a pleasure.